So in this lesson, you guys will learn how to find the average rates of change only for linear and quadratic sequences and functions, but mainly functions. And then you guys will determine the rate of change. Average rates of change for linear and quadratic functions. Determine the, what is happening? I can't read. Determine the change of average rates of change. So basically what that means is you guys are going to find the rate of change of the rate of change. What? What does that mean? Okay. So the first thing that we're going to talk about is the average rate of change, which is also referred to as the slope of the secant line. So it says the average rate of change of over the closed interval a to b is the slope of the secant line from the point a comma f of a to b comma f of b. So do you guys remember our formula y2 minus y1 over x2 minus x1, right? So in this case, does this make sense that this would be your x1 and this would be your y1? And then this would be your x2 and this would be your y2. You guys follow me? Okay. So then we could say that the average rate of change, remember, is the same thing as slope. So the formula we could write is f of b minus f of a all over b minus a. This is the same thing as y2 minus y1 over x2 minus x1. It's just a different way to write it. Okay? So here's a quadratic. What I want us to do is I want us to draw 2 points. So A, I'm going to draw a point right there. And then B. So B would be right there. So what I want us to do, guys, is I want us to draw a line through those points. There's rulers in the baskets. So basically what I'd be doing is, if this was my A and this is my B, does it make sense that this point right here would be A comma f of A? And then this point would be B comma f of B. So then if I do my formula, I would be able to find the slope between those 2 points. Okay? This line right here, guys, is called the secant line. There's also something called the tangent line. No, it has nothing to do with trigonometry, because you guys learned about secant, cotangent last year, right? Okay, that's what I was confused about when I first learned this. I'm like, wait, trig, what? They mean something graphically. These points are not that close, right? Do you guys remember how last week we were talking about we can get closer and closer and closer and closer and closer to a point? So if I were to draw A right here instead, does it make sense that these points are basically the same point? They'd be really close to each other. So then if I were to find the slope between those 2 points, this red line I'm drawing right now would be called the tangent line. But we won't really do that in here. That's more calculus, okay? But this is just introducing you guys to that idea. So in this lesson, you guys will learn about average rate of change of linear functions and also of quadratic functions. So let's start with this problem right here. So it says to find the average rate of change for each linear function. Okay? So average rate of change is the same thing as what? Slope, okay? So do you guys see how this is already written in y equals mx plus b form? What is the slope of this line? What? 2/3. So the slope is supposed to be 2/3. Now, I know you guys are smart and you guys remember that hopefully for math 3 and for math 1, right? But let's pretend like we didn't know that. So what I want us to do is I want us to pick 2 points. So let me pick like 0 to 3. So x is 0 and x is 3. And I love that they do this in the middle of class. I don't understand anything. So participate, guys. Slope is rise over run, right? So from here, I have to go up 2/3. Do you guys agree? So I'm just going to draw that. Up 2/3. So 2, 3. So m is 2/3. Bless you. What if I pick 2 different points? So instead of picking 3, what would be a smart value to pick instead of 3? Sorry, 3 comma. If I want to start at 3, what would be the next value I should pick? 6. So if I go from 3 to 6, so then if I do rise over run again, I get up 2/3. So it doesn't matter in this case where I pick my 2 points. Talk to me, guys. Does it matter which points I picked? No, because there's a slope change. No, good. Okay, so that's what I was basically trying to show you guys. It's the same. Hooray. Do I have to do that every time? No. So what's the slope here? M is equal to -2. So if I were to pick an interval, I'm going to pick -1 to 0. I could go down 2 and then over 1. What about number 3? Zero, right? Because is it rising or falling? No, it's flat. So from here to here, say 0 to 3, m is equal to 0. Could I have also picked like 0 to 5 or 0 to 4 or 0 to 1, right? So what do you guys notice about the rate of change for linear? Does it change? So I'm looking for a specific word that means it stays the same. Constant. Good job. The average rate of change for a linear function is constant. Highlight that because we need to know that. Regardless of the input interval length, the average rate of change stays the same. Okay. Is everyone good with that idea? Okay. So in this lesson, we're also going to be talking about the average rate of change of the average rate of change. That's weird. What's that from, guys? Hey, good job. I'm not that old yet. In like 20 years, kids won't know what that is. That makes me sad. Okay, pay attention to this because this is weird. So, we know the slope of this line was what? 2/3, right? So the average rate of change was 2/3, okay? But didn't I show you guys that we could do it a few times? No matter what points I pick, what is the average rate of change always gonna be? 2/3, okay? So this is what I wanna show you guys. If I do the A rock once, I get 2/3. If I picked other 2 points, I'd get 2/3 again. If I pick 2 other points, I get 2/3 again. Okay? Now, just for fun, because this sounds fun, what if I picked, or what if I want to do the rate of change of the rate of change? So what that means is, I'm going to do it a second time. But what I'm asking you guys is, I want you guys to look at these 2 numbers and then look at these 2 numbers. How did this change at all? Not a trick question. Did it change at all? So to get from here to here, what am I adding or subtracting? 0. And also 0. So what it's saying is, what is the rate of change of the rate of change? It would be 0. Because it's always going to be 2/3. Okay, same thing here. If I do it once, it'd be -2. If I pick 2 other points along that line, it would also be -2. If I wasn't convinced, I could do it again and get -2. Are you guys annoyed with me yet? Good, because this is supposed to be very straightforward, okay? So what's the rate of change of the rate of change? 0, 0. So it's 0. So can we predict what's going to happen in the last one? It's going to be 0. That's cool. So in general, the rate of change, the change of the average rates of change of linear functions is always what? 0. Cool. This will make more sense in calculus, because in calculus, this is actually called a derivative, and you guys will learn how to do that in calculus. Okay. Well, unfortunately, we don't just live in linear world. So now we're going to live in quadratic world. But these ones are a little bit more exciting. So if you guys are bored right now, this is a little bit more exciting, okay? So let's figure it out for a quadratic function. Find the average rate of change for the quadratic function x squared minus 2x on the given interval. Okay, if we didn't have a graph, guys, we'd have to plug in numbers into this function. But because we have a graph, this is actually pretty easy. So what I want you guys to do is when x is 1, I want you guys to draw a point. And when x is 2, I want you guys to draw a point. So when x is 1, it looks like, or I can draw a point right there. And when x is 2, it looks like I can draw a point right there. So if I'm calculating the slope of the secant line, I can draw a line through those 2 points. So on the interval, this is another way of writing from 1 to 2. This means the same thing, okay? Not a trick question, guys. What's the slope between these 2 points? What's my rise? 1. And what's my run? What's 1 divided by 1? 1. So the slope between these 2 points is 1 over 1, which is just 1. That was so much fun. Let's do it again. But now we're going to pick 2 different points. So I'm going to pick between 2 and 3 now. So when x is 2 and when x is 3, is the slope the same now? No. Okay. So what's my rise? What? 3. Thank you. I'm making sure you guys are awake. What's the run? 1. Don't think too hard. What is that? 3. All right, from 3 to 4. What's my rise? What? 5. And my run is? 1. So the slope is 5. Did you guys notice something? The run is always 1, good. How is this changing? If I add 2 to this, I get 3. If I add 2 to that, I get. So do you guys see how I'm going from 1 to 2? And then from 2 to 3. And then from 3 to 4. So what am I going to ask you guys to do next? From 4 to 5. Can we make a prediction? What should it be? Shouldn't we test it though? Yes. Because you guys aren't convinced yet, right? You guys are like, something's weird's going to happen, right? But the thing that sucks here is, do I have a graph for this? But do you guys agree I have the function, right? So I'm going to plug these numbers into the function. So this is going to be my A. This is going to be my B. The function is y is equal to x squared minus 2x. So to get f of A, I'm going to plug in 4 into x. You guys follow me? And do you guys trust me to tell you guys what it is without making you guys do it in your heads? I already did all the math on Sunday. I did it on Sunday assuming I was going to teach you guys yesterday. But then things didn't work out that way. So we're going to get 4 squared minus 2 times 4. 4 squared is 16. 2 times 4 is 8. 16 minus 8 gives me 8. F of B is going to be, I'm going to plug in 5 now. So 5 squared minus 2 times 5. 5 squared is 25. 2 times 5 is 10. 25 minus 10 is 15. Okay, so is everyone following me? So now to do the slope, remember it's f of b minus f of a all over what? B minus a. But what's b minus a always going to be in this case? How far apart are these numbers? 1, okay? So a rock is going to be f of b minus f of a all over b minus a. So in this problem, it's going to be 15 minus 8 all over 5 minus 4, which is just 7 over 1, which is, oh my goodness, 7. Raise your hand if you know what the next one's going to be. I see a few of you guys not raising your hand. What is it going to be, guys? I don't want to say names because I'm recording this and I don't know who's going to watch our video. What's the average rate of change going to be, guys? 9. Good. Do you guys believe me? Okay. So on your homework, please don't just say 9. You should show some work, obviously, right? But what is it? What's happening? What's it increasing by? 2. Okay. This is a new page of your notes, right? Okay. So in general, oh wait, because I get excited, sorry. Go ahead and tape it in. Okay. You guys ready? The average rate of change for a quadratic function does not stay the same, as we just saw. It was increasing every time by 2, right? However, for consecutive equal length input value intervals, the rate of change of the average rate of change for a quadratic function is constant. For the above problem, the constant is what? How much was it increasing by every time? 2. So this is the idea. Before we do these problems, this is the idea. What was the slope the very first time we did it for the quadratic? What was the rate of change? 1, right? So I want you guys to write this down. The first time it was 1. Then it was 3. Then it was 5, 7, 9, and we'll keep going, right? So this is what we call the first order average rate of change, because do you guys see how we only did it once? We found the slope once, okay? Now, the second order, so the next row, what I'm gonna ask you guys is, how did it change? So how far apart are those numbers? 2. How far apart are those numbers? 2, 2, 2. So do you guys see how all these numbers are the same? Okay, that also proves that this is a quadratic function. So how many rows do you guys see? I'm gonna wow you guys right now. How many rows do you guys see? 2. What is the power of this function? 2. So let's say it wasn't the same. So this is what we're gonna get into later. This wasn't the same. If I did it again and it was the same, that'd be a third row. That means this would be a cubic function. If the fourth row is the same, this would mean it would be a 4th degree polynomial. Does that make sense? So the number of times you have to do it to see that it's the same tells you what degree it is. So do you guys see how in this example, it was always the same? This is the first row, right? So that means it's linear, power of 1. It took 2 rows to show that this was the same, so that's x squared. Okay, does that make sense? Okay. So we're gonna prove it right here by finding the difference. So the cool part about this is it doesn't matter where you start. So I'm gonna pick -2. Now the key here is it has to be equal length apart. So I'm gonna choose numbers that are 1 apart from -2. So I'm also gonna pick -1. I'm also gonna pick 0. And I'm also gonna pick 1. And all I'm gonna do is I'm gonna plug in these numbers into f of x. Okay, you guys follow me? Okay, if I plug in -2, -2 times -2 squared plus 10. Order of operations, what is this? 4. 4 times -2 plus 10 is 2. -1, so this would be -2 times -1 squared plus 10. That's going to give me 8. If I plug in 0, 0 squared is 0 times -2, it's still 0. Plus 10 gives me 10. Okay. If I plug in 1, -2 times 1 squared plus 10, what is that, 8? So how many times did we plug in? 4 numbers, right? So this would be, right here, this is the first order. So then we want to figure out how far apart are these numbers to find the average rate of change once. and then we have to do it again. So how far apart are these numbers? Positive 6, right? To go from 2 to 8, do you guys agree it's plus 6? From 8 to 10, what do I add? 2. -2, thank you. You guys scared me. Okay. So this would be the first time. Does that make sense? The average rate of change between these 2 points is 6. The average rate of change between these 2 points is 2. The average rate of change between these 2 points is -2. You guys follow me? Okay. So is this linear? Are these the same? No. So I'm going to do it again. So what I want you guys to notice is, you guys see right here how it goes from 2 to 8, that's increasing, right? From 8 to 10, that's also increasing. But then from 10 to 8, that's decreasing. So these always kind of trip me out because I didn't learn it this way. But then when you do it again, it'll make more sense. Do you guys notice that these numbers are always going down now? What do I do to get from 6 to 2? What am I subtracting? 4. So this is a change of -4. And then from 2 to -2, do you guys agree that's also a change of -4? Oh my goodness. That means, and this is how I want you guys to write your answers, that the rate of change is changing by -4. Questions on what we did? And I should say this too. When you guys are doing these, try to do them without a calculator, because it's possible that this would be something that you guys would not be able to use a calculator on. Okay? Okay. For the next one, I'm going to pick, just to mix it up, I'm going to pick -1, and then 0, 1, and 2. To save us time, are you guys cool if I just tell you guys what the answers are? We all know hopefully how to plug in by now. Okay, so if I plug in -1, I get 5. If I plug in 0, I get 0. If I plug in 1, I get 1. If I plug in 2, I get 8. So these are the answers. So the rate of change now, from 5 to 0, guys, is that getting bigger or smaller? By how much? So this would be -5. From 0 to 1, is that getting smaller or bigger? Bigger, right? So by +1. From 1 to 8, that's increasing by what? 7? Okay. So now to see if this is quadratic, because this is the average rate of change once. So now I need to do it again. So to go from -5 to 1, is that an increase or decrease? Increase by how much? 6, so +6. And then this is also +6. Now, let's just say, hypothetically, we know it's quadratic, right? But these were not the same. Does that mean that this is not a quadratic? What would that mean? I mean, hopefully this doesn't happen, but what would that mean? Is it possible to make a mistake here? So if you get here, and let's say you get 6 and then like 4, that means you made a mistake somewhere. So make sure you go back and check your work. Okay? All right. So how am I going to write my answer then? Yes, the rate of change is changing by 6. Okay. Questions on this problem? How do we feel about this? It's not too bad? It is bad? Oh. All right. Last problem. This one's weird. Okay. I'll teach you guys it, and then I'll tell you guys how I feel about these, because I don't want to do it on camera. Okay. Concavity. The values of a function g are selected x values in the table below. The function is either concave up or concave down, but not both. Determine if the function is concave up or concave down. All right, so concave up. Do you guys remember teacup? Looks like a smile. Concave down looks like a frown or an umbrella. Okay, so which one is it? So the easy way to tell from a table is, first thing I want you guys to look at is we're going to look at the rates of change. So what I want you guys to notice is the x's. Do you guys see how it's a constant change? It's always going up by 1, right? So the change between these two is 1, 1, 1. What's the change between 18 and 20? Positive or negative what? 2, so positive 2. From 20 to 20, does that change? So I'm going to say 0. 20 to 18, negative 2. From 18 to 14, negative 4. So what I want you guys to understand is this is a rate of change. 2 divided by 1, do you guys agree that's 2? 0 divided by 1, that's 0. Negative 2 divided by 1 is negative 2. Negative 4 divided by 1 is negative 4. So what I want you guys to imagine is this is a function. So if the slope is 2, does this make sense that this could be like a line that has a slope of 2? At 0, that's just flat, right? At negative 2, it's going to look like this. And then at negative 4, it's going to look like this. So what I want you guys to imagine is the graph is going, I don't know why I'm doing this because you guys can see my laser, but it's going up, flat, down, and then down. Does that make sense? So what concavity is that? Down. That's it. It's concave down. So the function, let's write this down first. The average rate of change is decreasing You guys have seen this in my class, right? Those of you guys have had me before. What do those triple dots mean? Therefore, okay, good. You guys just know that too. Therefore, g of x is concave down. And then just for your notes, we're going to say also because the rate of change is decreasing over equal length input intervals. What that means is the difference between the x's was always 1. It's the same.